Hello, everyone, and welcome to a new video on logic, on statements and logic. So just to tell you what we did last time, we went over truth tables of those operations, namely the negation, the conjunction, which is also known by the and, the conjunction, which is also known by the or, the conditional, which is also known by the if then, and the last one, which is the biconditional, also known by if and only if statements. So, we learned how to construct a truth table of a compound statement, a statement that has probably three simple statements connected by those operators. Well, today we'll be talking about equivalent statements. So what does it mean to a statement to be equivalent, and how are we going to show, when they gave us two statements, how are we going to show if these two statements are equivalent? So let's get to learn that. So again, we will learn how to determine if two statements are equivalent. There's a law that is very important to learn. It's called the De Morgan's law. There are two of them, actually. De Morgan's law for logic. We can use these laws to actually determine if two statements are equivalent or not. And the conditional statement known by the if-then statement, remember the conditional statement, can also be replaced by what's called a disjunction statement. This is a very, very important in logic, because sometimes the arrow statement, the if-then statement, can be tricky to work with, but there is a way to replace it by a disjunction statement. Again, just wait till we get there and I'll explain to you how to do that. And we'll be talking about miscellaneous things like the negation of the conditional statements. And we are going to introduce three new definitions of the inverse, converse, and contrapositive of a conditional statement. But the most important thing is the De Morgan's law and the conditional statement being replaced by a disjunction. Okay, so two statements are equivalent if they have the same truth tables. So if I give you two statements and I ask you, are these equivalent? Well, then construct the truth tables of those two statements. If you get the same thing, if you get the same last column, then these two statements are equivalent. And when they are equivalent, we are going to use this symbol here, or this one here. It depends on the book you are using. So either they use this double arrow. Remember, do not confuse this with this one here. This is the biconditional. This is two statements are equivalent. And if you don't like to be confused, you can always use those three overlap in, or three dashes. I don't know how to explain this. Sometimes they call the equivalence symbol. All right. Let me give you an example. Suppose they give you this exercise. We have two statements. This is the first statement, it's a compound statement, and this is the second one. Are they equivalent? So let's build the truth table of this one here and build the truth table of this one here. And if we are having the same truth table, then they are equivalent. Actually, this is a distributive law. Actually, they are equivalent. We'll see. We'll see when they do the truth tables. Okay, well, here is the truth table of the first one, and here's the truth table of the second one. Remember, we have three letters. We have three simple statements involved, the P and Q and R. So if you have three statements, you have 2 to the power 3 rows, which is 8 rows. I'm going to have 8 rows. So let's start with the P. This is the first row for P, the second row for Q, and the third one for R. Remember, we have 4 T's. I'm sorry, we have 4 T's, and we have 4 F's, and 2 T's, 2 F's, 2 T's, 2 F's. 1 T, 1 F, 1 T, 1 F, 1 T, 1 F, and 1 T, 1 F. This is how you fill it up first, right? And then you do the truth statement. So P here, so this is the first statement. Let me call it statement 1, and this is statement 2. So P is T, when P is T, so you duplicate the column of P. Now you put Q and R, you put Q and or R. So T, true or true is true, true or false is true, and you keep building it. And then you put the conjunction between whatever you obtain from P and whatever you obtain for this, and this is your final answer. So by doing this, this is the truth table of S1. And this is the truth table for S2, right? The final answer is this one here. As you can see here, we get the same thing. TT, 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 FF, false, 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 and false, false. So we get exactly the same outcome or the same truth value for both statements. Now, if let's say two here, let's say we have F here and we have T here, then that's enough to say that the statement are not equivalent. All it takes is just one mismatch to say that the statement are not equivalent. So if these two statements are equivalent, what does it mean? It means that they are the same. So you can remove one and replace by the other and vice versa. There's nothing wrong with that. So like I just said, because the two tables have the same answers, count 3 for both tables, the statement are equivalent. Therefore, we can write, this is the first statement. This is S1, I call it S1. This is S2. Or we could have used this symbol. They are equivalent, so we can write that. So what we are learning so far, if I ask you if two statements are equivalent, say, okay, wait, construct the truth table for both of them. If you get the same thing, they are. If you get a mismatch, they are not. Okay, well, this is a long exercise. It says determine which statement is logically equivalent to the following. It is not true. So this is the statement. I'm going to underline it. It is not true that the tire is both out of balance and flat. Is this statement here that starts with this quotation and this quotation, is it equivalent to this one, or to this one, or to this one, or to this one? Well, as you can see here, they didn't give us the symbols. Like if I go back to the previous example, they gave us the symbolic representation of statements directly. So we don't care what P represents and what Q and R represent, right? But so to be able to do what we just did previously, we need, first of all, we need to convert everything to symbols, right? So how are we going to convert this to symbols? Well, we have the tire out of balance and tire as a flat. So we are going to have two statements. One that says the tire is out of balance, and the other one is flat, right? And then once we represent these letters or these sentences or these statements by symbols, then it will become a matter of just two tables. So let P, the tire is out of balance, and Q, the tire is flat. So this statement that says it is not true, remember when it is not true, you always start with the negations. It is not true that the tire is both out of balance, which is P, and you see, and what? Flat, which is Q. So now this one here is the symbolic representation of the statements here, just like I just wrote. So it's time now to go back to these statements and write down the symbolic statement of all these things. So if the tire is not flat, then the tire is not out of balance. So that's the representation of this one here. The tire is not out of balance, which is not P, or the tire is not flat. That's the symbolic representation of the second one. The tire is not flat, and the tire is not out of balance, and you see, and out of balance. If the tire is out of balance, P, if, then the tire is not flat, right? And this one here, we says it is not true that the tire is both P and what? And Q. So this statement, is it equivalent to this one here, or to this one here, or to this one here, or to this one here? So it's a long exercise. What we're going to do, we are going to build a truth table of this one here, and this one, and this one, and this one, and this one, and see which one of these truth tables matches this one here. It's pretty straightforward. So we're going to do the truth table. So here are the truth tables of all these statements. Okay, they are just representing them. So this is the truth table of the original exercise, right? So it is not true that the tire is out of balance and the tire is flat. And here they put the truth table of the first choice, the truth table of the second choice, the third choice, and the fourth choice. So the final answer is false, true, true, true. Which of these it says false, true, true, true? Well, this one is false, true, 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 right? So this statement is equivalent to this statement. So I'm going to say the negation of P and Q is equivalent to the negation of P or the negation of Q. Actually, this is a law. So we're going to see that later on. This is actually a law called the De Morgan's law. But I would like you to focus on the process. So if they ask you to show if two statements are equivalent or not, then one way to do this is to construct the truth table and to see to get the same thing. Now, if they give you these statements in words, then as a first step, you translate those words into symbols first. So, and then once you get the symbolic representation of these statements set up, then you can do the truth tables and you see if they are equivalent or not. Okay, so they are equivalent. So at the end, we can say, so it is not true that the tire is both out of balance and flat is logically to say the tire is not out of balance or the tire is not flat. So again, this is the same thing as saying this, believe it or not. So when you can say this outside of in the real world, and people may be accusing you of not being okay. Well, you can tell them that when you say it is not true that the tire is both out of balance and flat, is the same thing as saying the tire is not out of balance or the tire is not flat. These are the same statements. Okay, De Morgan's law. So to recap one more time, two statements are equivalent if they have the same truth tables. But we don't have to do the truth tables all the time because there are laws. And some of the laws, some of them, they are more than just De Morgan's law, but for this semester, we're talking only about these two laws called the De Morgan's law of logic. It tells you if you have the negation, it tells you if you have the negation of P and Q between parentheses, it is the same thing as, go ahead and remove the parentheses. If you remove the parentheses, this negation will go to both of them. And the end becomes the or. So that's what it is. So if you look, there's a pattern into these things here. It tells you if you have the negation of two statements connected by and is the same thing as the negation of these two statements connected by or. The same thing, if you have the two statements connected by the or and the negation of everything is the same thing as the conjunction, the and of the negation of the two statements. And these are known by De Morgan's laws. Actually, the last example we did, it was an illustration, was an example of this De Morgan law, the one I just circled. So from now on, if you have this, it's the same thing as this one here. If you have this one, it's the same thing as this one here. So you don't have to prove it using the truth tables. Well, you can always do that if you want to, but these are laws, just like you have laws in physics and laws in algebra. So you just use them, and because they are already proved to be correct, so you don't have to show the people that those are correct. Okay, well, here's an example. It says, write a statement that is logically equivalent to, it is not true. So when I say this is not true, I'm going to start with, it is not true that tomatoes are poisonous. I'm going to say tomatoes are poisonous. Let me say T is the statement or the letter that will represent tomatoes are poisonous. Or eating pepper cures the common cold. So it is not true that tomatoes are poisonous, or, you see, it says or here, or eating peppers cures the common cold. So it says, write this down another way. Well, we say that this is equivalent to, using the De Morgan's law, this is the same thing as the negation of T and the negation of B. So it's the same thing saying that this is equivalent to saying tomatoes are not poisonous and peppers do not cure common cold. So, well, instead of T, they use P. I use T, right? I use T for tomatoes are poisonous. Here they use P, the letter P instead of the letter T. Big deal, right? It's not a big deal, of course. Tomatoes are poisonous. They denote that by P. Eating peppers cures common cold. They denote that by Q. So it is not true that tomatoes are poisonous and eating peppers cures the common cold. May be written as the negation of P or Q. In my explanation, I put the negation of T, I use T for tomatoes, or P, I think, for peppers, right? Did I use P? Let me go back. I think I use P. Yeah, I use P for pepper. So it's the same thing, right? So they use P and Q. I use T and P. So using the De Morgan's law, so if you want to remove the parentheses, it's going to be the negation of P and the negation of Q. So therefore, it is equal to saying that tomatoes are not poisonous and eating peppers does not cure the common cold. These are the same. These two sentences are the same. These two logical statements are the same. So if you feel that I'm going too fast, well, you need to pause it and go back and forth till you get the hang of it, right? This is another equivalent statement. This one does not have a name. The De Morgan's law, we just finished them. These are another, I don't think this has name of this law has a name. It tells you if you have a logical statement of the form P, if P then Q is the same thing as saying the negation of P or Q. This is very important logic. So these two statements are the same. Well, you can always, if it bothers you, you can always construct the truth table of this one here, and you will see same thing as the truth table of this one here. So if you have a conditional, you can get rid of the arrow sign by replacing by the disjunction. That's why you see the title of this slide. It says the conditional statement written as a disjunction. You know, this is very important. So as an example, it says, write a conditional statement that is logically equivalent to the cows are in the pasture or the horses. You see the or, oops, sorry. The or here will be replaced by the disjunction symbol, or the horses are not in the barn. So as always, you need to symbolically represent things, and then you go from there. So let's represent this. We have two statements. The cows are in the pasture. That's the first statement. The horses are in the barn. That's the second one. So let's P be the cows are in the pasture, and Q the horses are in the barn. So the cows are in the pasture. That's P. Or the horses are not, negation, not Q. So this is the symbolic representation of this compound statement. It will be written as the P or the negation of Q. So this says write something equivalent to it. Remember, so the law we just did, we says if you have something, arrow something, is the same thing as, this is equivalent as the negation of the first thing or the second one. Yeah, well, what we have here, we have an or statement. We have an or statement, so we can always convert an or to a conditional. So this is equivalent to the negation of P implies the negation of Q. Yeah, because you gotta keep in mind that if you have the negation of P is the same thing as P. Just like the double negative in algebra, negative 5 is just 5. Negation P is just P. So this is, look at this, this is like my rectangle here, and this is my triangle. So if you have a rectangle, arrow, triangle is the same thing as the negation of P, which is P, or whatever you have inside the triangle. So let's watch what we're going to do it. So to write an equivalent statement of P or the negation of Q, negate the first statement, change the disjunction to conditional, and keep the second statement as it is. So therefore, if the cows are not in the pasture, then the horses are not in the barn is equivalent to the negation of P, arrow negation of Q. Well, there's another way to do this too. I hope this is not going to confuse you. If you have the or statement is commutative, when you say something or something else, you can interchange those things. For example, say P or Q is the same thing as Q or P. So this is equivalent to the negation of Q or P, which is equivalent to Q implies P. So therefore these two are equivalent. They are the same. Toward the end of this presentation, we're going to be talking about what's called the contrapositive of a conditional. I'm afraid that the jargon, the language of this topic will throw you off a little bit. Trust me, it is not that difficult. It's just new to you, definitely. because this is not the type of mathematics you used to algebra and adding, subtracting numbers and all stuff. This is kind of a brand new type of mathematics. I suggest, or I recommend that you don't give up on it. So just be patient with it. It may take rewatching this lecture again and pause it whenever you have an issue and investigate things and think about things before you go in fast. And of course, you are very welcome to get back with me, email me, call me, text me. We can hop on Zoom and clarify every problem you have. And also when you do the homework question, remember, there's always a button, I think to the right corner, top right corner, that shows you an example, shows you a video about it. So there are quite a few places where you can get help. Okay, let's keep going. So like we said, well, here's another one. Well, here's another one. So the negation of a conditional statement written as conjunction. Why is that? If you look at this one here, this P implies Q can be replaced by the negation of P or Q. Now, if you want to remove the parentheses, you put the negation of P, and this or becomes and you put the negation of Q. And what is the negation of P? Is P. So P and Q. So therefore, so the negation of a conditional becomes a conjunction. So that's why the title of this section or this slide says the negation of conditional is written as a conjunction, because this negation of the or becomes and. Well, here's an example again. Write a statement that is equivalent to the following. It is false that you hang the picture, then it is false that if you hang the picture, then it will be cooked. So again, you need to symbolically represent things. So we have two statements. You have hang the picture, you hang the picture, it will be cooked. So two statements. And if you see that if here, it is a conditional, and this is a negation. So if we translate this to symbols, if you put P, you hang the picture, Q, the picture will be cooked. It will be translated as the negation of, it is false that if you hang the picture, then it will be cooked. So which is, if you have the negation of the conditional, it can be written as a conjunction, which is P and negation of Q. So therefore, in words, we can say, you hang the picture and the picture will not be cooked. Yeah, so these two statements, from the quotation mark to the quotation mark, that's the first statement, is the same thing as saying this statement here. Okay, isn't that interesting? Okay, well, I think this is the last slide I'll be using here. This is just definition. Suppose you have a conditional statement. How do you read this? You say read if P then Q. If they ask you what is the converse of this, you just flip them around. The converse of this statement is this one here. That's the converse. You don't think about it, just so if you have R implies M, what's the converse of it is M implies R. So if they ask you what is the converse, just flip them around. If they ask you what is the inverse, well, take the negation of P, take the negation of Q, and leave the arrow in the same direction. So this is called the inverse of this one. So the inverse of this one is this one. And the contrapositive of this one here is this one here. I'm not saying that these are equivalent statements. Actually, the conditional and the contrapositive, they are equivalent always. And these are equivalent. Right? But you cannot say that the conditional is equivalent to the converse. Well, how can you tell? After all, you can just build the truth table, and you are going to find out that the conditional and the contrapositive are equivalent. What does this mean? It means that P implies Q is the same thing as the negation of Q implies P, implies the negation of P. For example, if it says, if it rains, then it is, or if it snows, it's more real life. If it snows, if there is snow, then there is cold. That's true. We know that when it snows, it's cold. It's the same thing saying, if it is not cold, it must not be snowing, which is true. So if it is not cold, definitely there is no snow, because if there is snow, there is cold. Yeah, I hope that this is not confusing. But again, if you have any questions, let me know and go ahead and start your homework. And when you do the homework, you will learn things even better. All right, guys, take care.